your test is going to be very similar to this study guide. Just like the last couple quizzes, we've done a quiz review in class, and then what did your quiz look like? It was basically the quiz review, right? So the study guide is telling you exactly what your test is going to be like. So the first couple questions, I'm just going to ask you to find the vertex and axis of symmetry. What is the formula we have to remember for that? Okay, remember, a is a number in front of x squared, b is a number in front of x. So my a is -1, my b is 10. What if there isn't an x term? It's 0. Okay, so when I do the opposite of b, the opposite of 10 is -10 over 2 times -1. So -10 over -2 is 5. The axis is a line, so you have to write x equals 5. The vertex is an ordered pair. So your 5 is your x, we have to find the y. To do that, you're plugging it into the equation. You can use your calculator. So it's the opposite of what we plug in squared plus 10 times what we plug in minus 28. So if you put in your 5, -3. So 5, -3 is your vertex. Okay, I want you guys to type this into Desmos for me. So, open up Desmos. And if you type in, what was it? -x squared plus 10x minus 28. All right, if you got confused, I did tell you, you have Desmos on the test, so you can use it to check yourself. Is my vertex at 5, -3? Yeah, you can graph it, you can click right there, and it tells you that order pair is 5, -3. So you can confirm it. Axis of symmetry is just x equals the x value of the vertex. So use your resources there. All right, I want to go down to number 4 for a minute. So on the graphing ones, you guys had to find the vertex. Number 3 wasn't a big deal because you did the opposite of b over 2a. When I look at number 4, so if I do the opposite of b, what is my b value? 0, because I don't have a number in front of x. There is no x. So it's the opposite of 0 over 2 times -1. So 0 divided by -2 is 0. Remember, that goes in the center of your table. Then you go smaller and larger. All right. Yes, you have Desmos on this, but you still have to be able to fill in all the information. Okay, so I have to be able to see a table of values. I have to be able to see those points plotted on your graph. Desmos is a great tool to check yourself, but it doesn't mean you don't have to do anything. So then you plug those in. So we get 3, 6. And everyone knows how to plug those in. Get your points. So we have -2, 3, -1, 6, 0, 7, +1, 6, +2, 3. You can use Desmos to look at the graph, but I will check. You have to have those points plotted that we found. Okay, so the axis of symmetry is just x equals the x value of the vertex, so x equals 0. The vertex is that ordered pair, 0, 7. What is the domain always? You can either write it out, or the notation, the shorthand I gave you is that double barred R. The range, so it's either y is greater than or less than. Since it's opening down, it's less than or equal to the y value of the vertex. So it's y is less than or equal to 7. All right. Let's talk about number 5. Because that one, can we do the vertex doing the opposite of b over 2a? No. when it was written like this, I told you to find it, you can take the inside of that parenthesis equal to 0. And you get -3. So that is the vertex. Or, the alternative, use Desmos. And I want you guys all to type in. So everybody has Chromebook. You can all do Desmos here. If you don't have it with you, look over your the shoulder of somebody next to you that has it. When I type this in, can I tell right now where my vertex is? Yeah. It gives me that point. So you can use that. You can get a lot of points on your graph from that or by plugging them in. So I don't care how you get them as long as you can. But if you had that question on the test and you weren't sure about finding the vertex, use Desmos. And I can tell. My vertex is at -3, -8. Okay, and then you do your smaller and larger. You're plugging those into your equation. So we get -5. What does that give us when we plug it in? -4? -4, -7, -2, -7, -1. And then we graph those points. So what's the axis of symmetry? X equals the x value of the vertex. X equals -3. The vertex was that ordered pair, -3, -8. Domain is always all real numbers. This one's opening up, so your range is greater than or equal to the y value of the vertex, which was -8. All right. Let's go to the next page. I'm going to talk about a couple of those. Not all of them. But if I look at these, I want you to tell me the transformation. Now, if you got confused, number 6, maybe you don't remember what that negative does. If you type that in, okay, what does that negative do to my graph? Flips it and made it upside down. Okay, so when you're telling me the transformations, the negative out in front is flip, or we could say reflect either, over the x-axis. What does a +6 on the end do? All right, number 8. If you multiply by 2, what does that do? Vertical stretch. Okay, remember the trick I told you? If you add to x, go left. If you add to y, graph will go high. Okay, so adding to the x moves it to the left, so subtracting would take it right 5. Adding 4 on the end would move it up 4. All right, number 10. If I ask you to tell me the equation, so we're starting with x squared. If I want to compress it by 1/4, that's the same thing as shrink. Stretching and shrinking just means you're multiplying by 1/4. If we go 7 to the right, if you add to x, it goes to the left. So if you subtract from x, it goes to the right. And then we have to go down 1. So it gets a -1 on the end. So everybody better be writing these down. This is part of your homework. I'm doing it with you and giving you correct answers. So make sure you're getting those and have those corrected if you made a mistake. So then we got into the ones where I'm asking you to find your zeros by graph. If I give you a table, you have to fill in the table, but you can use Desmos to help you. Number 12, how do we find the vertex? Over 2a. My a is -2, my b is +8. So the opposite of b would be -8 over 2 times a, which is -2. So we get -8 over -4, which is 2. Alright, now we have to plug these in. Alright, you three put in -1. You guys put in 0. Back row put in 1. Dave and Holden put in 2. You guys put in 3. I'll do 4 and 5. Alright, -1, what'd you get? 0, what'd you get? 1, what'd you get? Back row, somebody tell me. 2, what'd you get? 3. Okay. So -1, -18 is off my graph. I'm not going to do that one. 0, -8. 1, -2. 2, 0. 3, -2. 4, -8. Zeros are just where this graph touches the x-axis. So where is that? It's the only point. It's when your y is 0, so you're just looking for that. Sometimes there's 2 of them, sometimes there's none. The factored form, we didn't really do that. We talked about it, but if 2 is the solution, that means in your parentheses you had to have x minus 2, so that when you plug it in, you get 0. We know from our factoring, we always had 2 parentheses. Since we only got 1 0, they're both the same. So it's x minus 2 and x minus 2. What did you guys get for the zeros on number 11 when you graphed it? Okay, so if you think about our factoring, when we are solving by factoring, it's always the opposite. So if you had -5, that means it was x plus 5. If you had -3, it was x plus 3. They're always the opposite sign. Alright, I am going to take a little break. I want you guys to, let's check the first couple and see how we're doing. On these, remember, you're looking for 2 numbers that multiply to -45, add to +4. What are they? At this point, we set each of them equal to 0. Alright, so to move a -5, you would add it. So we get +5. To move a +9, you subtract it. So we get -9. So those are my solutions. Did you guys get that one? Okay. On these, they always have to be equal to 0. So on 14, the first thing we have to do is subtract over the 5. And then we check for a greatest common factor, but there isn't one. However, these are both perfect squares, so we can do a difference of squares. So it would be 5x plus 2 and 5x minus 2. Set them equal to 0. this, we subtract our 2 over. How do you get rid of a times 5? So we get negative 2/5. This one you add over your 2. Divide by 5. And you get positive 2/5. So on these, our strategy, we factor and then set them equal to 0. Alright. I'm not going to look at all of these, but let's talk about 16. Before you do anything, the entire equation has to be equal to 0. So what would I need to do? Okay, 16x squared is a perfect square, but 10 is not. However, when I look at these, they're both divisible by 2x. So we're essentially just going to divide that. We're going to factor it out. So that gives me as 8x minus 5. Once you get to things multiplied equal to 0, you set each one equal to 0. Divide our 2. So we get 0. Divide by 8. And we get 5/8. Let's talk about a couple more of these. So I'm not doing all of them, but I'm trying to hit a few to refresh our memory. Number 18. We want everything to be on one side. We like our x squared to be positive. So what I'm going to do is add over my x squared and subtract my 3x, because we need a 0. So we get 0 equals, I don't have any other x squareds. 1x minus 3x is negative 2x. Minus 15. So now we're factoring. We are looking for two numbers that multiply to negative 15 and add to negative 2. What would those numbers be? Positive 3. Oops, negative 5. So if we set those equal to 0, if this part is confusing you, write out the equations. It's just each parenthesis equal to 0, then it's solving an equation like we did at the beginning of the year. So you subtract your 3, and we get negative 3. Add my 5, and we get positive 5. So negative 3 and 5 are my solutions. Let's go ahead and do 20 together. We need it equal to 0, so I'm going to subtract both the 7x and the 5. So that's 6x squared minus 7x minus 5 equals 0. We don't have a greatest common factor. Nothing comes out of all those. So this is when we did slip and slide. So we multiply the 6 down. Now I need two numbers that multiply to negative 30 and add to negative 7. What would that be? Negative 10. Now, this is probably the step that we forget most frequently. We started out multiplying this 6, so you do have to divide it back. But you can go ahead and just set them equal to 0 from there. 10 over 6, that reduces to 5 over 3. So if we add that over, we get x to be 5/3. 3 over 6 is 1/2. that over. We get negative 1/2. I would like to review a little bit here. So on these, we talked about using Desmos. 24 we can tell is a graph. Remember, linear is a line. Quadratic is a parabola. Exponential growth or decay is either a curve going up or a curve going down. So what's 24? When you get to the other side, like 25 and 26, you can just graph those on Desmos and tell. The tables are probably the ones we struggled with the most. And we talked about patterns. So you can use Desmos to try to plot the points, but that's sometimes hard to tell. So we're looking, do we add or subtract to get from one to the other? Or do I have to multiply? Okay, to get from -5 to 25, we can add 30. To get from 25 to 59, we add 34. To get from 59 to 97, we add 38. If it's linear, we have to add the same number every time. So I know right now this is not going to be a linear one. For quadratic, we look at the second difference. How do you get from 30 to 34? From 34 to 38? If the second difference is the same, that's quadratic. That's a parabola. Alright, or you can use Desmos and plot the points on a table and see. When I look at 22, how do I get from 38 to 26? 12. To get from 26 to 14, subtract 12. From 14 to 2, we subtract 12. If those are the same, that's the first difference, so we call that on 23. I'm getting some pretty big numbers here, so I don't think I'm adding. To get from 7 to 28, you could multiply by 4. 28 times 4 is 112. 112 times 4 is 448. If you have to multiply, it's exponential. If you're multiplying, we call that growth. When we had to divide, that was decay. So since I'm multiplying by 4, it is getting larger. Or I can look, my y's are rising. Or if you plot it on Desmos, you'll see that curve going up. So that is exponential growth. Alright. I'm going to do one last problem, then you'll have the rest of class just to work on finishing this. Remember, it's due tomorrow, along with any other late work that you might owe me. On 27 and 28, on the test I will have these, and I'm going to say you can use Desmos, but you do have to draw me a picture of what Desmos gives you. Okay, so I want everybody, 27, let's do that. So everybody pull up Desmos. And graph the first one. Okay, so you do the first one in your Y1, the second one in your Y2. When you get those graphs, you have to be able to give me some exact points on your table. So if you click like your parabola, it automatically puts a few points for you that are easy to tell. So we can use those to kind of help us, like -2, +5 is a point on that graph. -1, 6, 0, 5. You can look at the table, or if you just hover over the graph, when you click on it, it gives you some points automatically. Is everybody seeing that? Everybody got those points show up? So that's all I really need here. I want you to plot a few points so you can put your graph in the right spot. Then my line, if I click my line, it tells me a few points on it. -2, 5, 0, 3, 1, 2. My solution is where they touch, and you have to give me those ordered pairs. So you can click on Desmos, we can see from our graph, it happens twice. At -2, 5, and at 1, 2. And so you do have to write those ordered pairs down. Are you guys okay with using Desmos to get those graphs? So, keep working on your study guide. Let's get